In this episode of Scaling Postgres, we talk about foreign key indexes, graph queries, Linux huge pages, and text column size. I'm Kristen Jameson, and this is Scaling Postgres, episode 192. All right, I hope you, your friends, family, and coworkers continue to do well. Our first piece of content is, should I create an index on foreign keys in PostgreSQL? This is from Procona.com. And they're saying, no, a lot of the advice, and I've even given it, is that generally, you want to have indexes on your foreign keys. And these are references to other tables that are frequently used with querying. However, it's not always the case that those would be used. So they present an example here where you have a supplier table and a product table. And most of the time you're going to be looking and searching for products and just wanting to know who the supplier is. So for that type of query, you're not going to be needing an index on the supplier ID. You would only need it if you are looking at products from a given supplier. Now, clearly that would happen, but it's probably not going to happen as frequently. So do you need an index on it? And some of the arguments they're making is that it may be more efficient just to do a sequential scan of the table. But of course, they also discuss the flip side of where having an index on a foreign key is pretty much essential. So when you have a customer and you have orders, a lot of times you're just going to be looking up a customer's order. So in this case, this foreign key would be essential for those types of queries. But this post basically talks about it's not always essential to have indexes on foreign keys, although I would still probably do it as a first pass unless I'm sure it's the case like above here where it's not going to be used that much, because you can always add the index later. And even if you've added one, Postgres has tables that let you examine how frequently that index is being used or if it's being used or not. So it's a good practice to use those views to look at Postgres and remove any indexes that just aren't being used. But if you want to learn more, you can check out this blog post. The next piece of content is webinar graph queries with PostgreSQL. And this is on the EDB YouTube channel. And this is a webinar about an hour in length, and he explains how you do graph queries with PostgreSQL. And basically, graph queries are where you have separate nodes that are linked or there's relationships between one another. An example I typically think of, you have a person that has relationships. Maybe it's a friend relationship or a familial relationship. Those are links between two different areas. Or you could also have a graph query that looks at where different HTML pages are and how they're linked together. Well, how you do these types of queries in PostgreSQL is you use recursive queries. So you use the with recursive keyword to recursively search through those trees, essentially. And this webinar goes through how you can write queries that run efficiently, use indexes, that can also avoid circular references, which are possible with a graph, as well as handling multi-paths to the same node as well. So if you're interested in that, you can check out this YouTube video. The next piece of content, improving PostgreSQL performance without making changes to PostgreSQL. This is also from enterprisedb.com. And this post is basically all about Linux huge pages. Now, we've had some other presentations about it, but as your database scales, this becomes more and more important to look at and configure. So it's basically an operating system level configuration, not a PostgreSQL configuration, although you do have to make an adjustment. But this discusses the importance of it, as well as some of the magnitude of the changes. So they say when they were working with one client, after configuring Linux huge pages, the CPU usage of one database system went from 51% down to 15%, with essentially the exact same load. So that's definitely really significant. And they give you some queries here you could use to check out the status of the page table to see if you could potentially benefit from this. So they go about discussing, hey, does this make sense, and how to check that out. And then once you're ready, making the change even in a test system and testing the results. So you can definitely see some TPS adjustments based upon how you configure Linux huge pages. And I really like the advice at the bottom of this post. The first thing, set up a test server. Make sure neither transparent huge pages nor huge pages are enabled and run a test load. Then repeat with the 2 megabyte size huge pages, record the results, and then repeat it with the 1 gigabyte huge pages, record those results as well, determine what's best for you, and then choose what you want to put into production. So this is a great post about Linux huge pages that I definitely encourage you to check out if you're running a larger size database. The next piece of content, does varchar n use less disk space than varchar or text? I personally have always heard that there's essentially no difference between these, but he actually set up tables and tested all sorts of different character lengths to examine, is there a difference? And he has the table right here, and basically for anything greater than a string length of 100, the results are exactly identical for all different column types, both the text column, a varchar, and a varchar with a specified number of characters in it. The only two areas that were different is where the string length was 10 or 100, and that was for a varchar of a specific number. But he narrowed it down to what he believes is the presence or not of a toast table for it. So basically, it pretty much looks to me like all of these are identical, and it doesn't really matter which you choose in terms of disk space utilization. But if you want to learn more, you can check out this content at depsc.com. The next piece of content, using PostgreSQL views in Django. This is from pganalyze.com, and they're talking about using views, which are basically virtual views of a table. And you can create a view that looks at multiple tables, and it basically is a way, as they say here, to cut down on complexity. So as opposed to having to join the same tables over and over again and rewrite a long query, you can simply write that query once and save it as a view using the create view command. Now you can simply select from this view to get the information of interest. Now, these are virtual tables, but you can also materialize them, which is what a materialized view is. So you're actually creating a separate table and putting the data into it. A standard view has no data stored in it. It always just goes and reads directly from the tables. But a materialized view actually creates that table. Now, the advantage of that is that now you can put indexes on it to get potentially better performance. And they talk about how you can create it. But the other thing you need to keep in mind is that now that is a static representation of a point in time. And if you want up-to-date data, you're going to have to refresh that materialized view. So they have the command to do that. And ideally, you're always going to want to concurrently refresh it. And then the latter part of the post shows you how to set up and use these views in Django. Because in terms of Django, they're essentially just another model that you can define. And I've personally done the same thing with Rails. I've set up views and created models that point to those views, and you can use them for reports, for example. But if you want to learn more about how to do that, you can definitely check out this blog post. The next piece of content, Phriday, isolating Postgres with repmgr. This is from enterprisedb.com, and they're talking a lot about high availability with regard to repmgr, which is essentially a rep manager. And specifically, this talks a lot about consensus as well as fencing and how it handles those cases with Rep Manager. So if you're interested in that, you can check out this blog post. The next piece of content, PostgreSQL on WSL2 for Windows, install and setup. This is from cybertech-postgresql.com. And WSL2 stands for the Windows subsystem for Linux. So basically, it's kind of like having a virtual machine infrastructure within Windows. So if you set up this WSL2, you can essentially install a Linux distribution within Windows with presumably better performance than you would get from, say, a VM solution. And this talks about installing PostgreSQL in that type of an environment. Now, they're referencing a Stack Overflow survey here where they show a lot of people are using Windows for their development environment. Frankly, a lot of what I see is Mac, so I'm a little surprised Mac's only 25%. I'm a little surprised that Linux is this high at 25%, but the Windows subsystem for Linux is about 3%, but there are some users out there. I know personally I use Linux on the desktop, and I have for years. I used to predominantly use Windows, but about a decade ago when I started Rails development, I pretty much switched over to Linux. But this post shows you how you get WSL2 installed on Windows, and then how you can then get a Ubuntu distribution and install it on that, and then from that point, install PostgreSQL on it and be able to connect to it successfully. So if you're interested in that, you can check out this blog post. The next piece of content, waiting for PostgreSQL 15, allow publishing the tables of schema. This is from depesc.com. And basically, they've made an enhancement to logical replication where now you can also define a schema that you want to publish. So before you could publish individual tables or the whole database. Well, now you can do it at the resolution of the schema. So if you're interested in that feature, you can check out this blog post. The next piece of content, PostgreSQL 15 will include some more regular expression functions. This is from migops.com. And they're talking about Postgres 14 and prior have a fair number of regular expression support within a number of functions that they provide. But this post was discussing that Oracle provides even more. So this individual or organization put in a fair amount of work to add a lot more regular expression functions to Postgres that should be live by version 15. So if you're interested in learning more about that, you can check out this blog post. The next piece of content, easily running Babelfish for PostgreSQL on Kubernetes. This is from stackres.io, and they're talking about Babelfish, which is the open source project that allows PostgreSQL to act like a Microsoft SQL server, essentially a line-compatible version. And since the source code has recently been open sourced, they've used their solution, their stackres operator for Kubernetes, I believe, to easily enable you to run Babelfish on it. Now, they do provide a hosted solution, but it appears that there is an open source version as well that you could try out. So if you want to try a Babelfish without having to compile Postgres from source code, maybe you would like to try out this alternative. The next piece of content, the PostgreSQL Person of the Week, is Louise Grandjonc. If you're interested in learning more about Louise and her contributions to Postgres, definitely check out this blog post. In the last piece of content, we did have another episode of the Rubber Duck Dev Show this past week. This one was on what is DevOps. So if you're interested in a long-form discussion about DevOps and what it is, you can feel free to check out our show. That does it for this episode of Scaling Postgres. You can get links to all the content mentioned in the show notes. Be sure to head over to scalingpostgres.com where you can sign up to receive weekly notifications of each episode, or you can subscribe via YouTube or iTunes. Thanks.